All right, welcome back. So hope that you have the concepts of return-oriented programming, and you guys are okay with everything, right? So it's basically time for us to do some demonstration and try out some cool stuff. So let us try to do activity, uh, and for this I'm going to use 64-bit Linux machine. Right? So I'm going to use a 64-bit Linux machine, guys. You need, if you want, you can do it on a 32-bit machine as well. So, but I'm planning to use a 64-bit Kali box. Right, 32-bit also would be all right. So no harm. So my Kali, they are good. All right. Let me. Might need this as well. Sublime. All right, so good to go. Right. Okay, so now we are going to start with doing this. So, we are assuming that we have a program code with NX enabled, right? So we'll write the code and we'll try to get it done. And next thing is you might need a bit of tools here. So let me do what. Okay, so I'm going to create a directory called ROP, and we'll do things from here. That's in this folder, right? So I'm in the prop folder. There's nothing here. The first thing is I need the Python pip, right? So to do these things, I need Python pip. Oops, I need pip. Do I have it? Oops, no. All right, what's happening, guys? Come on, not find Python pip 3 of it. Okay. Okay. Alright, so let me check. Pip 3 is another. No? Yeah, pip 3 is there. Alright, so I hope it will work. Yeah, we'll continue from here. So I need all right. All right. So we were doing the demonstration. And again, and now it's time to start it again. Okay, I believe we have. Okay, we have to install Python pip. So we'll go as sudo apt-get install Python pip. We might need this. Oops. Okay, so it should be Python 3 pip. I guess I installed Python 3, so it's all right. So it's installed. All good. Then I need to install this particular library called Capstone, which is a Python library which is needed to So what I'm going to do actually, just to not to keep you in blind, so I'm going to first install the software which is required. We need something called wrapper. So this is to get the gadgets. This to get gadgets automatically. After that, I will basically write a program, vulnerable program code. Then we'll do the exploitation. So there are like we might have to add a bit of things. So we will go with this in detail. But right now you'll understand what I'm going to do. Right, so I'm going to install Capstone. Okay, good. So we need the pip for that. I have already installed it, so I don't get any other messages. So make sure that if you don't have pip2, so you have to use pip3 command. All right. Then I need to use the wrapper library. Basically, I download it. Here I don't have anything, so I'm going to do clone and https://github.com shs wrapper.git. Okay, so let it download. Right, so everything good. So wrapper, wrapper status, everything is updated, all good. Okay. Okay. Right, now what I have to do is I need to update this. So I'm going to pip submodule, say init, init, just that. And the next is to do update in case if I'm missing anything. So it will bring down whatever necessary. Alright, cool. Right, so now I think everything is fine. So I'm going to write, so all the codes are there, guys. So I'm going to use this wrapper.py. So this is what I'm going to do. If I need to install, so there's requirements in the text file, and then there's a setup.py which you can run. All right, so then I will be able to run that. All right, so all good. So what I'm going to do now, I'm going to write my code. So let me name it as rop.c. Right. Let's start writing my code. So basically, you don't have to think too much about this one, but what we are doing is we are writing a basic vulnerable code. This can be reused at many times, so I'm going to put some good content into this. h, so int overflow. So this is the function which we are going to create yeah, so we are going to create this with some vulnerability. Okay. So I'm going to read any characters or 500 characters into the buffer and then print okay, printf the buffer content buffer content and SMD, and we'll get the buffer content here. So R and you in the buffer. Good. And return C. Int main, so I'm going to write the main function argc char. You guys can skip this section. I'm not really explaining anything here. Printf that's starting. Okay, yes. So that's the starting point of the program, and then the overflow function call. You don't have to pass anything. Return 0. Okay, it's very good. So what I'm going to do now is to compile this. So when I'm compiling, so I have the file. All right, good. So I'm compiling. I'm going to use. So we discussed about this. So this is to disable the stack canaries. So now you know about it. Protector and ROP.c minus OROP. Okay. Oops. That's an error. That's it. So you should. Yes. So yeah. Okay, what's the issue now? Undefined reference to name. Let me open it up. Oops. Yeah, that's all good. So I have my binary. So let me check. That's the ELF 64-bit LSB charged object. So if you can remember the last time that we did it, We had issues with shared binaries, but we don't have it right now. Here we don't have a problem with 64-bit versions. Right, so now we'll deal with this. Now what we're going to do now, we are going to open this with GDB. All good. All right, that's okay, that's fine. That's another concern. That's all right. Now I'm in this GDB Peda, so you guys can use this as a tool if you want to. Now, Peda is good because Peda gives you a lot of better options, right? So it's good to deal with a tool like Peda. So if you want to get Peda installed, this is what you guys have to do. Oops. Okay, so so this is the command. You can do a quick search in Google. GDB Peda install. So if you go here, we'll have all the details. And so there are a few tools which can be quite useful. So you get all this interesting visualization on that. So this is the command, guys. I already installed it, so I'm not going to do that again. So you can install that. So Peda is a great tool. Okay. And of course, yeah. So we'll go to the installation again. Sorry. Okay. Now what I'm going to do, I needs to. The whole purpose of opening the GDB in the given instant is to okay. Okay, to check my file, so I'm going to do that. Check sec. Okay, so I'm in the wrong. Okay, I should be here. Zoom in a bit. All right, now it should be all right. Peda check sec. Alright, so everything is fine. So canary is disabled, so I have used that command. No stack protector, and also this thing called 45 also disabled. And okay, so index should be enabled, and this pi we don't use the pi, so we can disable that as well. Let me check this. I'll do Google search. How to disable pi and nx. Yeah. So I don't need the pi. So it might get make some complications. So I don't need that. So please understand these sort of things. You have to use these techniques. So it says this is if you want to disable ALSR to canaries. If not protector, I use that. But I'm looking for something else. That is no pi, I believe, as I remember. Yeah. So this is the one. To disable pi, so you have to use this dash no dash pi. Okay. Yeah, that's what I have to use. Go here, exit, Control Z. I'm going to recompile this with the NoPy flag. Okay, good. Okay, so now I'm going to open up the GDB and then I want to check my file again for compile options. Check all this stack overflow, security. Yeah, so everything is fine. So NX is enabled. So this is what I'm planning to do, guys. All right. So now what I'm going to do is we are going to do something called fuzzing, right? So this is quite important. So the overall idea now for me to do hereafter, let me get my notepad. So I have run the vulnerable code and I know what's happening. So in the exploitation step, I need to get in touch with the RDI. So why RDI? Because RDI is the registry which used, later on you will see that, which used uh, for which used to return, right? Return to system function, right? Systems function. So if you can remember, we said that use a system libc or libc systems function, and then of course we use the binls command, and also here we have to use a gadget also. We are using gadget also to create our flow. So those are things, but first of all I need to find out where is the RDI located in this particular program. So there are few things that we can do to find out the RDI and the address of that. So there are you can use a tool like Metasploit, but easily from Peda we can create a file of a pattern, right? So let me create the pattern create. So there's this macro called pattern create 500, and I'm going to use the written so function file called pattern. So this will create a pattern of 500 characters and it will save to a file called pattern. So now what I'm going to do is I'm going to run my program with this pattern file. So okay, so this would basically run it with this input. All right, it's cool. So what will happen here is, as you can see, the program crashes. Yeah, that's all right. The next step is to examine the last element in the stack to calculate the offset, right? So to get into the RDI, so we need to get the offset of ESP, right? So to do that, so as you can see, we have the return here. So that's the location that we are in. All right. So and then we have to get the RSP. All right. So so we might get this one. This is the point where it got overflowed. So I'll copy this for the moment. Okay. Copy selection. Paste. Okay. So that might be needed. So now I want to get where's the ESP or the RSP, because this is being so if you look at this, there's nothing more to understand. So this is a pattern that we filled in. So this is the stack actually for the stack here, the stack. This is stack, and then this the code, right? So everything that's so at the moment the code is here, right? So it got returned. So we have to find out where it got returned. So I'm not going to analyze the code here. So we're just getting the place where the return. So that's we can identify. So even we can get this particular address if needed, but this particular moment we are not really worried about it. And yeah. So and also you find other things, related things, RIP. So RIP is the instruction pointer. If I want, I can get a copy of that as well in case. So I'm going to copy that here. Okay, what else I need? Now for the moment that would do. Right, okay. So now, I have copied a few things here. Without knowing, that's all right. So now I want to get some idea about the address where at RSP. So to do that, I would do x-x RSP. Yeah, I don't think we get ESP here. Yeah. So because it's RSP, yeah, that's all fine. So, but I need this more details. So I'll do a W here. Oh, sorry. Yeah, so I get the last element of the stack, which is the RSP. So I'm going to copy this RSP, which is this one. So cool. So that is recorded. And also now let's see whether the offset of this pattern and the next offset will be the exact offset of RIP. Right. Alright, so we have to derive the RIP from this. So again, we can use the PEDA option. So for that, I'm using PEDA pattern offset. Right. So don't worry if you are hearing these options for the first time. Nothing to worry about it. It's basically like serif options in the PEDA tool. Edit, copy, paste. Oops. What is the issue? Undefined command. Yep, always a mistake. Done. Okay, so now what happens is, now we are looking for the offset of offset is the memory in between RSP and RIP, right? So of course RSP is the starting point. So after 104, you find RIP. So we need to find the RIP, no? So we need to know where it is now. So actually the exact offset for RIP. So because it's so RSP here is here, and after 104 bytes, you will find the RIP. So the meaning of that would be RIP will start from 105 offset, right? Not the address, direct address, but 105. All right, so we can confirm that as well. Right, so for this, actually, I think we need a bit of a program. So I think to get the location and all that. So I might have to write that down. So quickly move away from this. All right. So we are going to write a small Python code. So Python codes are very important. Later on, the next session, I'm going to do this phone tools. Phone tools is quite useful to do these sort of things. But we'll do it without using phone tools now. So Python now. Use bin env Python. So I'm setting the into point, and then we are going to use old method here, but it's okay. Struct. That's just like because struct which uses packing and unpacking, basically encoding and decoding for binding to string. You will see because we are using a lot of bytes here, and then of course we have to convert it to string. So here also it's all strings, no worries. So I'm going to create a so this is a buffer. I'm going to append things to the buffer. So just remember, this is like creating like a shellcode sort of thing, right? So it's like pattern, string patterns, because I'm going to overflow the function, which is the ROP function, or ROP like ROP file. So 104, because we have to fill up to that point, right? So basically all this would be junk, right? Just junk. All right, so then I want to add a bit more to actually go through the RIP, so then we can identify what are the values. Okay, that's fine. So then of course this should be going to a file. All right. So we say open and then input text W for writing. Oops, sorry. No semicolons in Python. So I just moved from the C code. So I'm going to write the buffer to the function. Everything is cool. Please don't run this with Python 3. So I had a long time fighting with some of these things with Python 3. So you might have some problems and you get stuck for a long time. So don't do that, please. Okay, now I'm going to compile this with Python 2. Cool, everything is cool. Yeah, so no errors, exploit.py is here and it has created the input.txt. So this is the file that we build up the pattern. I'm going to do a cat and I can see all my A's and my B's. Cool. Now I'm going to run the GDB again. GDB :ROP. Ooh. Okay. It's a bit sloppy. I think my machine is getting stuck. It's okay. All right. Now what I'm going to do, I'm going to run now this with passing input.txt from the folder. I let it go. Yes. So now, as you can see, we are here. Where are we now? Okay, and you can see very clearly when we get into RIP, so we have 42, 42, 42, which is correct because we have added B's, right? So you can see added B's, RIP is there. So we are on the right track, right? So everything is fine. Right? So we know that what we have gathered earlier as a RIP is all right. Now, since the index is enabled, we can upload and run a shellcode. So you understand that now. So we have what you do is you have to use ROP return oriented programming with the return to libc. So we are using return to libc. So we are not doing gadgets here. A lot of gadgets here. We use one gadget, and which enables us to call from libc, right? Which could enable us to call the function, right? Hence, we will use a system function to execute shell commands. So what we're going to do is basically to look at the systems page, right? I think I can do a man here, man system. Can I? That's the cool thing about Peda. You can do that. So you can do all these things. The system library function uses fork to create blah, 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 blah. And then you can do this and you can get any of these commands. So I think at the previous session, I said bin.ls, it should be sh, right? So you can the shell. Yeah, that's cool. Yeah, so that would do the job. So what we need is the address of the system function. You have to get the address of the system function. So in exploitation, we have to get the address here. All right. And also find the function, also location of the string of the shell command, and also bin ls. We need to get the location of this as well. All right. The only thing we did was to copy the location of the string into the stack. So that's what we do. Now we need to find a way to copy the location of RDI register to enable system function to execute the ls command. So how the pattern works, you have to find the RDI, from there to systems, and then there to bin ls. So to get the RDI, we are going to use a gadget, right? So location of the RDI, because these things are not very clear, you can find it from the stack. We have to use ROP gadget, which you can extract the address of the string and copy it to the RDI register. And also because this is very important, because RDI register, because the first argument should be the RDI register. Right. So we have to get a ROP gadget. So to do that, so because we need to get into the RDI. So we need to have a gadget here. So that's basically function code, right? So basic code, right? So what I'm going to do now, I'm going to run the ROP. Alright. So I need to go to the proper folder. Okay. Now what to do? All right. Okay, what I'm going to do, I can run the wrapper.py. Let me check running this. Yeah, it's working. No issues. Everything is fine with wrapper.py. So what I'm going to do is I'm going to give the file. The ROP file was in the previous directory. That's where ROP is. And then I want to search for, because I was looking for the RDI. So I'm going to find a gadget. So this will find gadgets, right? So if you just search, I believe they will bring out a lot of gadgets. Oh, load gadgets from here. So there are plenty of gadgets. See? So how many gadgets are here? Plenty, right? There are a lot of gadgets. So this is why I said even a small program code, there are so many gadgets. Right? So 104 gadgets were found. So we don't need all of these. So these are different commands. You can see pop, retire, or return. So what we need is we need to find something which need to find out RDI. So I need to search for RDI to do that. Yeah, I think I have to put the ampersand RDI. Okay. What just happened? There are few actually, no. Truly, I need this pop RDI because I need to get the argument from the RDI. So I need this one. So this is the address for that. So I need to have a pop RDI return. So that's what I require. So I will get this. Okay. So if I go here, this is that address. Right. So I need that. Now we need to find out where exactly the system. Right. So I found the first one, the gadget. Then I need to find the rest. All right, guys. Okay. So I need to go to the gdb./ROP. Okay, here. Then I need to find the location of the system. All right, what is that? No symbol table is okay. So I haven't run this. I have to put a. Let me check. Disassemble. I didn't do anything like that. Even needs to. Okay. No symbol table is loaded. How bad it is. Okay. Nothing is there. Let me see. Alright. Some issue. Okay. Gotcha. I'm in the wrong place. See, it's always good to do your basics. Hey. Okay, that's fine. Disassemble the main. Alright, so we have the overflow function. So disassemble the overflow. Okay, so there you find the read and the print, basic stuff. I don't need them anymore. And if I do a system, of course, even it will not print me because I have not run it. Break main, break point down, and then I have to run. Okay, that's good. So now I should be able to find That's the system is. All right, good. So you can see it's libc system function. The address is this one. All cool. All right, copy this now. So I'm going to copy it here. That's fine. Okay, a bit more. Okay, now what I have to do is to get the location of bin ls. So for that I need to find function and bin ls. All right, good. So that's also done. So I find two results, both are same or different, but I'll get this one. Okay, so all good. So I found everything that I require to run my exploit code. So I need to now find out a pattern. I found out a pattern, so I had to build exploit code. So remember, every time you had an exploit code. So the logical order should be in the stack, the address of the system function, and then the string pointer will be popped from the RDI, and ROP gadget for the exact pop, right? So that's basically it, no? So I need this bit, so I will remember now. Sorry, I don't need that. So what I need is the address of the, so if I'm building this logic, address of the system function, and the string pointer which we popped, string pointer to pop the RBI. So that's the string pointer, so it's this, right? And finally we need the ROP gadget. ROP gadget will only pop the required ROP gadget to extract the pop, right? So that extract the pop, so to do that I need the ROP gadget, last element from the stack. All right, so now I need to run the exploit code. To get that code, I need to again write a Python. So I don't like writing all this, but anyway. So I'm going to modify the exploit.py. I have the code here. So what's happening? All right, so. We should go out from here. Exploit.py. Okay, what I have to do now? This one is fine. This one is fine. This one I don't need now. I don't have to check for the basic. I don't have to check the RIP. Okay, but I need to fill things here. So initially I want to get the buffer added. Now this part is important. So basically what I need to add is the ROP gadget. So I should go from bottom to top, ROP gadget. So as my ROP gadget, this is my ROP gadget. So I need to add this next. All right, I'm going to add it here. Oops. Oh. Insert no direct edit page selection. Okay, that's good. And then I need to basically, this is a byte. All right, this is a byte. I try to understand. So I can't add a byte directly to the buffer. So I want to convert this to a string, and I order this as a byte as well. To do that, I use this function called pack. So pack will do everything. Or else you can do the encoding also, guys. And in the pawn tools, we have other cool other ways also, but this is the one method. So that is done. Then I need to fill the buffer. What is the next one? So again, we have to do a pack. Right? So that would be the same. Q. All right. So what is the next one? Actually, pointer to the string, right? Pointer to the string. So ls, no? So that should be this one. Edit, copy. So please make your notes, guys. You have to continuously make your notes. Right, edit, paste. Okay, that's basically is the pointer to bin ls. Right? Right write anything here, buffer. Okay, now what you have to do, of course, the system, no? So see, like what I'm going to create is we are going to create a overflow code, right? An address of the system function. Hope I have saved it, otherwise I'll do it again. Oh, yeah, I have it. This is the address of the system function. Edit, paste. Okay. Every time. So use Sublime to do all this coding. It will be much easier. See, it's not pasting. That's that. Edit, copy, come here, and paste. Fine. Oh, what is that? To get the system. Okay. Oh, I have replaced it. Just happened. It's on the system. Okay. So if I do that, it will not work. Okay, hold on. Yeah, so I might have to save this quickly. So I will be able to do this. GDE ROP. This time we get it right. So you'll be learning this anyway, how to do these things. Alright, then what we do, break on main and then run. Okay, and the system. Alright, I can directly copy this now. This is what I require. Copy. I'll paste it here anyway. Paste, done. Move out from here. Done. From here. And then I'm going to paste this here. Okay. Bit more to go. All right. Then into text, everything. So I'm going to use Python. Exploit. Oops, back. Okay, so use Python 2, please. Don't use Python. I told you. So if I can do the cat. Perfect. So you can understand this thing. It's okay. So now what you're going to do. All right. Let's see. So this is the final part. So now we'll see the exploit will work. GDB. ROP. So fine. Now we have our input text updated. Right. Bit more. Now we have to run with input. So everything goes fine. We will see what other files in the folder because bin.sh runs. So it gets the shell and get all the commands. It runs. It shows the commands. Let's see. Running. What's happening? Oh yeah, all good. See, you get your files. So basically it has run. That's fine. So don't worry about all this command because I have installed another tool called Pwn debug. So there's some issues. Don't worry, it's not really important. But this is the part which is important. All right. So basically, I have done a very neat exploit. I know it's a bit difficult to understand, but don't worry. We are going to do another 250 exploits in the same way. Then you will understand the rest. All right, guys. So do this one, and we'll discuss them. All right. Thank you.